Hello everybody, how's it going today? My name is Connor and welcome back to another video. In this one, I am going to be kind of going over how my actual application works that I've created here with the logic simulator. Going to be talking about like as if you were going to actually use it for something, right? It's gonna be like a little quick and dirty tutorial on how to use it, I guess. Um, so uh, First things first is it is a interpreter for a parser for this scripting language I've created called the padls scripting language. And it looks something like this. And I don't have syntax highlighting for this a bit bigger now before I forget. Don't have syntax highlighting for this in Visual Studio Code because I haven't written a language server or a grammar for it yet. But hopefully I can get something like that going soon. It's probably a project for later on. Either way, going to create a new file. It's called video.padls. And the basic syntax of how this works is you can think of a paddle script as like a bunch of different connections between signals, so binary signals. So every variable, every kind of binding, as I call them, in padls represents either a 1 or 0 at all times. No other values, nothing in between. It's all binary. So it can be high or low. It's a digital logic simulator. That's what digital means, is, represented by discrete values. So, um, so to define a circuit in padls, you give the circuit a name. So I'm going to call this one main because this is the one that looks for to attach everything else to, right? So you do an open square bracket, and you give whatever binary inputs you want to have into your circuit. So I'm going to give it one input called A, and then you do space dash greater than, make a little arrow, and then you can give it some outputs. So I'm gonna do one called out. Right now, you hit enter. You do some curly braces. Now you can define some connections and some logic going on between your inputs and your outputs. And you can define temporary values in here as well. So like say, I'll get into that in a sec, but for now, let's just do out. And we're going to connect out with another arrow. This is kind of going in another direction. Directly to A. And with a semicolon. Hit save. And now in order to run padls, you can get rid of this press backtrace, but you would basically just run that executable, or if you're running from source code, you do cargo run. Right now, you have to run in release mode in order for it to really work, or else it'll give you an error related to the async runtime. I really don't know what's going on there, but running in release mode always works. So, and then pass it the thing you want to run. And then you shall be greeted. Now, hopefully my audio doesn't glitch out here like it did last time, because it's using the GPU for encoding as well as the simulation. But if all goes well, you should have a clickable thing over here. And then you see the output over here is automatically detected. The A input is automatically detected as well from the source code. And these are now connected together. That whenever A goes high, out goes high. And whenever A goes low, out goes low, because that's the operation that we've defined here, right? You can ignore the stuff over here. This is like stuff same with displays, kind of, or like numerical displays and a clock, which is not quite connected to anything. We're not even running, actually. So you can see the source code in the middle here, just as like a nice little feature display. So now let's do something a bit more complicated. where we have multiple inputs and maybe even multiple outputs. So if you don't have more than one input, you just add a space and you separate them with spaces. So you can do A and B, and do out 1 and out 2. Okay. So it's important to know that these all must be connected. All your inputs and outputs must be connected, or else it will error. I'm pretty sure. It might not actually error, but we can find out. But I'm not gonna do that right now. So now just connecting things together is not very interesting. So let's go ahead and do something like some binary logic. So we could do out 1 is so when you want to do like this is we do like A and B, right? So I'm pretty sure if this is correct, yeah. You need to. Will that work? I wonder if that'll work. Do like a out to A or B, right? So this would be a binary and. This would be a binary or. See if that works or not, because this is a syntax error. Yeah, okay, that doesn't give us a syntax error. So you need to put start on these parentheses. That's just for clarity. Pretty sure this will work now. Yeah. So now we have our out 2 being A or B, and our out 1 being A and B, right? There we go. So when A and B are both high, out 1 will be high, and if A and B or B are high, then out 2 will be high. So we can actually rename this and or, and then let's do an XOR. And then A XOR B, and this will be familiar syntax to you if you're if you are a programmer at all. And you know, and or XOR, these are all pretty common logic gates. You want to do like a NAND gate, like a NAND. So it's do like a NAND NOR XNOR. We could do like this, where we invert the outputs. I don't know if that's actually what an XNOR gate is, but either way. And this will add a NOT gate at the end of that, end of the outputs. So we have all kinds of logic gates going on, you know. And with these, you can do all kinds of really cool stuff. So now, what if you want to make something like a latch or like a cross-coupled latch or a flip-flop or something? Well, you can actually do that as well in padls. And if you don't know, sorry, that's my other video that I made a while back. If you don't know, latch circuit. So a latch involves some kind of cross-coupling between two NAND gates or two NOR gates. This one looks like it uses NOR gates. But that means there's a feedback loop going on here. So one of the outputs is being fed in as one of the inputs. So how you would do that in something like padls is, let's actually go through it step by step here with it on the side. So, come on, here we go. Do it with that on the side. Get rid of you for now. And let's go ahead and put this in its own circuit. So you can actually do other circuits other than the main. So let's do latch. Let's do SR latch. Set and reset. Right. So we have our two inputs, set and reset. And then we have our two outputs, Q and Q bar. right? Following so far? So how you would connect this up in padls is, well, first of all, we need two NOR gates. So we're going to be doing something with set NOR Q bar, actually, because you see this is connected to Q bar. And even though we haven't connected up Q bar to anything yet, we can actually do this by doing Q is connected to not set or Q bar, right? Because that's how it's connected up in the circuit diagram. You can do this very literally, actually. So Q is connected to set and Q bar, or not set or Q bar, nor set nor Q bar, right? And then the same thing for the Q bar is now defined as Q bar is not reset or Q. And even though these are our outputs, we can still use them in our circuit, which allows for feedback loops, right? So that's one thing that padls does allow for is these feedback loops. So let's go ahead and set reset Q bar, and we can just use the circuit as if it were another logic operation. So Q, oh yeah, and if you want to like unfold, if it, like something has two outputs, you want to unfold it, you just type both of them basically. The Q and Q bar is connected to SR latch of set and reset. Go ahead and run this in an emulator. Now you'll see that we have kind of an unstable circuit over here because the SR latch is naturally unstable by default. But if we go and hit one of these high, then it will stop oscillating like that. And it will stabilize into the state of Q low, Q bar high. We hit reset, it'll toggle that. Or we'll flip it back to Q being high, Q bar being low. So, see what I mean? So now we have a little latch, which we can use to store a bit of information. Sorry. That's pretty cool, right? Little feedback loop. It behaves exactly as we expect by looking at the circuit diagram and what it says it's supposed to do. So, yeah, really, that's all there is to it. And gonna walk you through, now that we know how the syntax works in padls scripting language. Whoopsies. Let's go ahead and walk you through something a bit more complicated, which is what I was using to test the script I was using to test the GPU implementation. So this is a simple, it's actually 4 data flip-flops, D flip-flops. And you can see they're all in unstable states right now because I haven't hit right yet, but see, these are all writing low now. I can set A, B, C, whatever I want, and I can write it and it'll write it into those data things. So you can see this is just made up of really simple like logic gates at the end. And it's important to remember, I should have stressed this at the start actually, that each line of these circuits happens in parallel. So all this stuff that's connected together, this isn't like a program in C or in Rust where this happens and then this happens. No, these are actually connections, as if they were physically connected by a wire, right? Which means everything happens all at the same time inside one of these little blocks. That's really important to remember. That's kind of the catch with things like this. It's very similar to something like Verilog. If you are familiar with Verilog, I know someone commented on one of my videos recently asking if I knew about Verilog. I do know about Verilog. It was one of the major inspirations for this project. So you can have something like a D-latch, which is very similar to an SR latch, except it has an initial set of gates at the start to add a bit more stability. Sorry about that. Someone's messaging me on Discord. I didn't realize I had that open. Anyway. What was I talking about? Yeah, so you can okay, sorry, I ignored that. Special guest, I guess. Friend I was talking to. Okay, that's embarrassing. Anyway. Yeah, so you get the idea. Each one of these things happens in parallel. It's just a bunch of gates all connected together. I think that's enough of explanation for now. Just a real quick update on the state of the application itself. I'm now no longer using a mutable common state that I'm operating on. I now write it to a separate buffer, and then that's just rewritten into this state input on every polling iteration. So, anywho, yeah. Also, just as like a quick demonstration of what I can actually do with padls. This is a much more complicated script that I've done. This actually makes use of numerical displays to this is an 8 banks of 8 bits, something like that. Yeah, 8 bits of RAM. It's 8 bytes of RAM. So I can hit reset here, and then I can select a bank with these 3 bits, right? The S1, S0, S2. Sorry, I can't make this bigger, by the way. I wish I could, but it just does that. So sorry for the mobile users. But this is S0, and I can select which RAM bank to write into. I can input a value like that. Do something like that. And then I can hit write. It'll write that value in binary into that RAM bank. And then I can select a different one. And it can write a different value, like something like that. And then I can go back to the first one, and it should remember it. Yeah, 88. So anyway, that's the script for this. It's really complicated. It also has a bunch of other stuff that's not currently being used, like an entire arithmetic logic unit. So yeah, it's a little nuts what you can make in padls right now, and I'm looking forward to making more. Anyway, that about does it for this video. Thank you all very much for watching. I better respond to my friend. Thank you very much for watching. I'll see you next time. Peace out.